Welcome to this video in which we continue with aggregate planning. In last week's video, in the last video, I went over using Excel to do an aggregate plan. I didn't finish it towards the end, so let me briefly go over it again. If you remember, so one of the things that I forgot to do in last week's plan, so let me go back in here. So a couple of changes. First, the starting inventory is 1000. I used a starting inventory of 1500 last time, so it should actually be 1000. So that's one change. And the other change that I made, and this is an important one, is to realize this. So let's say that if I solve it with an inventory of 1000, the aggregate plan looks like this, but this is actually deceptive. It is deceptive because if you look at the number of workers who are laid off, you will notice that it's 51 point, excuse me, 51.42. Now, there are a couple of ways of thinking about it. So, laying off 15.42 workers is technically possible. How is that possible? It's possible because you're essentially saying that you're going to lay off 15 workers, and the 16th worker you're going to make them work part time. So they're not going to work full time. They're going to only work part time, and they're going to work instead of they'll be working 58.4% of the time basically. So that's possible. But if that is not something that you're going to allow, and that's how the textbook manages it, so one of the things that we have to do is to make sure that the number of people you hire, the number of people you lay off, and the workforce, all of these numbers are actually integers. So they cannot be decimals. You cannot have any decimal values in it. So you go to the solver and add a constraint which says that all these variables, the number of people you hire, number of people you lay off, and hence the workforce. In fact, you don't need the workforce piece. Let me change that again. It's just the number of people you hire and the number of people you lay off. These two sets of decision variables have to be integers. So you're going to int. So remember, we did binary when we were doing capacitated facility location models, but here we're saying integers. By integers, we mean that they have to be whole numbers, counting numbers basically. They cannot be any decimal places here. So by adding this extra constraint, if I click on solve, you'll notice that the value is pretty close. So instead of laying out 15.4 workers, you'll be laying off 16 full workers, and this is the solution that's in the textbook. So that's why our numbers were slightly off from the textbook. So we started with an inventory of 1500, and I didn't input the fact that these values have to be integers. So with this, this is what the aggregate plan looks like. Now, what we'll do in this video is we'll go over a few variations of this aggregate plan. So one of the things you'll notice is that demand in this case is pretty variable. So it starts at 1600, goes all the way to 3800, and then comes down to 2200. So that's a pretty variable demand. So what we'll do is we'll look at another example where demand is even more variable, right? So what if demand is even more variable? So if you look at the textbook, there is a here is an example of higher variability in demand, where demand starts at 1000 and goes all the way up to 4800. So let's look at a higher variability in demand. So what I'm going to do is, let's see if I can copy. Yes, I can copy these numbers over. So this aggregate plan, I'm going to call it original. Now let's make a copy. Aggregate plan, high demand variability. So high demand variability. So here, oops, just text. So here we have demand variability being much higher. So everything else is the same. All the cost values and everything, they are all the same. The main difference is that we have demand that is highly variable. So if that's the case, what does our final solution look like? So let's click on solve. There you go. So this They all have to be integers, so we get a 500. Okay. Looks like we end up with the same answer, but I don't know why it's giving it the same answer. Oh yeah, so it is the same answer, but the main difference here is that the cost does go up. So even though you still fire 16 people, what you should notice here is that you are more likely to stock out than in the case where you have this, and the total inventory that you hold is much higher. So 5100, 4200. So you hold a lot more inventory, and so your inventory costs go up, and the aggregate plan so costs go up from 422,000 and odd to 433,000. So it's almost $11,000 more than what you had before. So that's just the change in variability in demand, right? So you can actually tie the variability in demand to change in that. So even here, you're still laying off 16 workers. So you end up with 64 workers for the whole planning period. It's the same. We end up with 64 workers for the whole planning period, but still, because of variability in demand, the total cost goes up, right? So what if demand was not as variable as it is before? So let's say that I make a copy. Let's make another copy. Low demand variability. Right? Let's call it low demand variability. So if low demand variability. So these are the original values. So instead of going from 1600 all the way to 3800, let's say that demand. So if you look at the average value of demand, the average value of demand is around 2,666 values. So let's say that demand was 25, around 2500. So let's say that it began 2200, 2200. Right? So with this demand there is way lower variability in demand. With this, if you click on solve, you'll notice there's a substantial change. Now you'll be laying off way more workers. I think the main difference here is the average is 2667. The average is 2667. Okay, so yeah, so this obviously you'll be laying off more workers because of this. So let's make that. So let's make it 2,700. 2000. Sorry, 2,600. 600. Yeah, so approximately 2677. So that's okay. So with this, if you click on solve, right? So you're laying off 17 workers instead of 16 workers that you're laying off. You're laying off one extra worker. And the cost is substantially reduced, not just because you laid off one extra worker. Remember, laying off a worker costs you $500 as opposed to $300 for hiring a worker. So you are laying off an extra worker, but your inventory costs are much lower. This time you're not doing any stockouts. You're doing some subcontracting, but absolutely no stockouts at all. So given that, and the values of inventory here are much lower. Inventory peaks at 3920, costs peak at 3920 here, but here the inventory cost peaks at 1840. So it's a substantially lower inventory cost, so your overall costs go down. So demand variability has a huge role in how costs vary, especially when you're making aggregate plans, right? So that's one thing. The second thing is, what if hiring and laying off was cheaper? Right now we are saying that it costs us $500 to lay off a worker and $300 to hire a worker. What if those values were different, right? So what if the costs of hiring and layoff were lower by $50, right? So just talking about hiring and layoff being lower by $50. So I'm going to go back here and I'm going to make a copy of this. Right. There's an aggregate plan with lower personnel cost, lower hiring cost. Okay. So this is where the hiring and layoff costs are. Instead of referring to the original data, I don't want to make change in the original data. What I'm going to do is hiring costs, instead of being $300, I'm going to make it $250 for hiring. Let me make that difference. And layoff costs, instead of being $500, I'm going to make it $450. Right. Now let's solve the problem. So they're both lower by $50. Is it only hiring cost? Lower hiring and layoff cost. Oh, I guess the textbook is going to make them equal to $50. Let me just want to follow what's in the textbook, if I remember correctly. Right. So I think the hiring cost was $50. So let's take this back to 500, and let's say that this is $50. So you are bound to make more changes here. You're laying off 14 people. You're laying off 2 more people here because hiring cost is much cheaper. This is the original cost values here. Let me, yeah, that's $500. Yeah. So there you go. Let's also change the layoff cost this time and see what happens if hiring and layoff costs are both $50. It's much easier to hire and lay off people. Now you'll notice that you're doing a lot more hiring and firing. So the cost of hiring is $50 and the cost of layoff is also $50. Then you'll basically try to match hire and layoff. There's only one month. This is the month with the highest demand, where you will have some stock out and some contracting values, but otherwise you will be doing a lot of hiring and laying off. If hiring and laying off is cheaper, and of course the cost will be lower because the cost of hiring and laying off is so much cheaper. So that's the idea there. So all of these things play a huge role. But if hiring and laying off costs are decently higher, you will tend to have a constant workforce, right? So that's something that you should keep in mind, right? So this is it. So I'm going to end this video here. There's one more video that I'm going to do in the aggregate planning series. Later on, we'll continue this with the sales and operation sales planning series that'll come next week. But I'm going to finish this video right here. Right. Take care.